The chemistry behind cake. Salt is a common ingredient used in cake baking. The chemical formula for table salt is NaCl, also known as sodium chloride. This is an ionic compound. Chlorine's outermost electron shell is completed by snatching sodium's single valence electron. Chlorine is extremely attractive.
Sugar is a key ingredient in the sweet taste of cake. Granulated sugar is also known as sucrose. Sucrose is a mixture of bland glucose and extremely sweet fructose. This creates the perfect amount of sweetness.
Water is also known as H2O. This ingredient in cake helps hold all of the dry ingredients together.
Flour is the main ingredient in cake. Often it contains trace amounts of copper, chromium, and zinc.
As we gather ingredients, we can observe some quantitative properties. These properties are exact numbers and measurements. Some examples include 2 eggs weigh 4 ounces. Milk has a density of 64.6 kilograms per meter cubed, and an egg is 7 centimeters tall. But wait, in chemistry, we use the International System of Units. We can correct 4 ounces to 113.4 grams.
Qualitative properties deal with descriptions and data that can be observed but not measured, including textures, colors, smells, tastes, etc. In our ingredients, we observe that the eggshells are white, the butter is soft, baking powder is gritty, and vanilla extract smells sweet, but it tastes bitter.
As we begin to mix our ingredients, many physical changes are happening. Mixing the batter, breaking the egg, and salt dissolving in water are all examples of physical changes because they change form without changing identity.
As soon as our ingredients are mixed, we put in the oven at 350 degrees and observe a chemical change. A major chemical change occurs with eggs, but we'll talk about that later. In a chemical change, atoms are rearranged and the atoms change. This cannot be reversed. When the cake is done, we notice a change in odor and color.
Matter can be broken down into multiple subcategories. From matter branches pure substances and mixtures. Within pure substances, there are elements and compounds. In cake baking, we don't have any single elements. We have many compounds including flour, baking powder, and sugar. Within the mixture category, there are homogeneous solutions that are the same and uniformed throughout the whole substance. These also include metal alloys. In our recipe, batter would be considered a homogeneous substance. A heterogeneous substance would be the final cake with icing because it is not the same at every point and has different layers that can be physically separated.
Some solids in our recipe are sugar, flour, and baking powder. The particles in solid are packed very closely together, they cannot be compressed, and they have very strong bonds. Liquids in our recipe are milk, water, and the inside of an uncooked egg. In a liquid, particles are held together with intermolecular forces. They cannot be compressed and hold very weak bonds. The uncooked cake batter has a high viscosity, which is the resistance to flow.
When eggs are cooked, protein molecules uncurl and create new bonds with other protein molecules, giving the cake its structure.
Baking powder has a unique backstory. At one point, it was baking soda, NaHCO3, which is bitter and has a high pH and less balanced with an acid. Baking powder is baking soda, which has already been neutralized with an acid. This ingredient helps leaven the cake by producing CO2 bubbles to make the cake light and fluffy.
Now you know the chemistry behind baking cakes. The final and most important part of baking a cake is eating the cake.